Imagine shrinking yourself smaller than an atom, smaller than an electron, into a hidden world where particles appear out of nowhere, collide violently, and disappear in less than a second. For decades, scientists struggled to understand this invisible chaos. The mathematics of particle physics became so complicated that entire blackboards filled with equations still could not fully explain what was happening inside the quantum world. Then one man changed everything. Richard Feynman looked at the problem differently. Instead of drowning in equations, he started drawing pictures. Simple lines, tiny arrows, wavy curves. At first, they looked almost too simple to matter. But those strange sketches became one of the greatest breakthroughs in modern science. They were called Feynman Diagrams. And today, scientists still use them to understand the deepest secrets of reality. Before Feynman diagrams existed, particle physics was a nightmare. Scientists were trying to combine quantum mechanics with Einstein's relativity. But every time they calculated how particles interacted with light, the equations exploded into infinity. Physics itself seemed broken. Then Feynman introduced a revolutionary idea. What if particle interactions could be visualized? Instead of impossible equations, he drew interactions like tiny maps. For example, imagine two electrons moving toward each other. Normally, you would think they simply pass by. But in reality, they repel each other by exchanging particles called photons. In a Feynman diagram, straight lines represent electrons, and a wavy line represents a photon. That simple drawing explains one of the most important forces in the universe. And somehow, it produces incredibly accurate predictions. But the deeper scientists explored these diagrams, the stranger reality became. According to quantum physics, empty space is not actually empty. It is filled with invisible activity. Particles constantly appear and disappear from nowhere. These are called virtual particles. Right now, all around you, space is boiling with quantum chaos that humans cannot directly see. Electrons exchange invisible photons. Quarks exchange gluons. Matter and antimatter briefly flash into existence before vanishing again. The vacuum of space is alive. And Feynman diagrams help scientists understand this hidden world. One of the strangest ideas connected to Feynman's work is that particles do not follow one simple path. Instead, particles explore every possible path at the same time. An electron moving from one place to another does not travel like a tiny ball. According to quantum mechanics, it can move through multiple paths simultaneously. Feynman called this idea the sum over histories. It completely destroys normal human intuition. Even Feynman himself admitted that quantum mechanics is almost impossible to truly understand. He famously said, "I think I can safely say that nobody understands quantum mechanics." And yet, the mathematics works perfectly. Today, scientists at CERN still use Feynman diagrams inside the Large Hadron Collider. Every collision between particles can be represented using these diagrams. In fact, some particles were predicted by these diagrams before they were ever discovered in experiments. That is how powerful Feynman's ideas became. But despite all this success, physics still has massive mysteries. Scientists still cannot fully explain gravity, dark matter, or the true origin of the universe. Which means our understanding of reality is still incomplete. And perhaps the most terrifying idea is this. Everything around you is built from invisible particle interactions. Your body, light, heat, matter itself. The solid world you experience every day is mostly empty space held together by quantum forces. Reality may not be made of solid objects at all. It may be made of interactions, probabilities, and invisible energy exchanges happening every second. That is what Feynman diagrams truly revealed. Not just how particles move, but how reality itself may actually work. Richard Feynman passed away in 1988, but his strange little drawings continue to shape modern physics even today. From black holes, to antimatter, to the search for new dimensions, scientists still rely on his ideas to explore the unknown. Because the deeper humanity looks into the universe, the stranger it becomes. And maybe somewhere beyond our current understanding, even bigger secrets are still waiting to be discovered.